Good morning to everyone. All of you can able to hear my voice?
Yes, sir.
Yes, sir.
Today I'm going to start with JK flip-flop. Next flip-flop type is called as a JK. Okay, next flip-flop type is called as a JK flip-flop. So already you know that the flip-flop is nothing but one of the memory element. It can able to store one bit of information. That is called as a flip-flop. So different type of flip-flops are available. In the last class we have seen SR flip-flop. The next one is called as a JK flip-flop. Okay, the JK flip-flop JK flip-flop is same as SR flip-flop. Okay, but how it is a differ from uh, SR flip-flop in the sense in the SR flip-flop they are not defined. Suppose the input value equal to both are equal to one in the sense they defining as that is called as a uh, forbidden state. Am I correct? Here what happened? They provide the definition for if the input combination one is occur, they will defining what is the output. Okay, this is a way JK flip flop. It's a differ from SR flip flop. It defined it defined for J and K equal to one. If both the inputs are one in the sense they defining that and and perform complementation. Okay, I will tell that. So what they given is complementation. For example, my input, for example, J and K, both input are one in the sense they will defining it. So what is the output of this function in the sense? Suppose the previous state. For example, already you know that how the sequential circuit is working on. The sequential circuit is working on based on the current input plus past output, previous output or otherwise called as a past output. Am I correct? Okay. Here what they given is if both inputs are one in the sense, it will look at that fast output. If the fast output equal to zero in the sense, what happened? It perform its complementation. Okay. Suppose the fast output equal to one in the sense, what happen is, okay, it perform its complementation. Okay, whenever the input combination is a 1 1, I will tell that briefly. Okay, so what is the truth table for SR flip flop? What is the truth table? S and R. What is the Q? Okay, and then okay, they defining it. If both inputs are 0 0 in the sense, what happened? It will retain previous stage that can be represented as a no change. Suppose the input combination is 0 1. Okay, 0 1 in the sense what happened? It is called as a reset stage. Reset state. Okay, what is the meaning is if R equal to R value equal to 1 in the sense, okay, the Q value equal to 0. Next combination 1 0 in the sense the output value equal to 1, and then 1 1 in the sense that state they called as a forbidden state. That state they called as a forbidden state. What is the meaning of the forbidden state in the sense? You are not encouraged to allow that input combination. So now I'm talk about the truth table of JK. Already defining that the JK flip flop, the JK flip flop same as SR flip flop. Okay, what is the SR flip-flop? Okay, 0, 0. 0, 0 in the sense, what happened? It will retain the previous stage. So instead of no change, what happened? I can return as like that. So what is the previous state output? It can be retained. Instead of no change, what happened? I can return as Q of n. Okay. Now what is the next input combination? 1, 0. Okay. So they look at the table. If s equal to 1 in the sense, what happened? The output value equal to 1. Here j value equal to 1. Definitely, okay, the output value equal to 1. Similarly, 0, 1, the 1 otherwise called as a set state. If k equal to 1 in the sense, what happened? You look at that SR table, what is the value? R equal to 1 in the sense, what happened? So its value is a 0, 0 otherwise called as a reset state. Okay. The next they will defining it. So what they defining is, if 1, 1 in the sense, if the input combination is the 1, 1 in the sense, what happened? What is the previous output? What is the previous output? It going to take its complement. That is the output. That is a truth table of, that is a truth table of JK flip flop. Okay. Do you have any queries? Do you have any queries? Hello. Do you have any queries?
No, sir.
No, sir.
Okay.
No, sir.
So next, what I'm going to do, I'm going to talk about what is the meaning of characteristics equation. So already last class we have seen what is the meaning of characteristic equation. The characteristic equation, it's a talk about the behavior of that flip flop. Okay. The characteristic equation. Sorry, first we talk about the characteristics table. The characteristics table is talk about the behavior of flip flop. Behavior in the sense, suppose my jk is a in flop, and then along with that, what happen? I'm going to provide previous output. Okay. I'm going to predict that what is the next stage output. Okay. That is called as a characteristics table. So what is the meaning of characteristics table in the sense, it will tell that the behavior of flip flop. Okay. This is a three, I'm going to provide three input jk and then previous stage output, that is called as a q1. If I'm going to provide that, okay, what is the next stage output? Okay, that is called as a characteristics table. Okay, here three variables are there. Three variables in the sense, how many number of input combinations are available? 8. 0, 0, 0, 0, 0, 1, 1, 0, 1, 1. Similarly, 0, 0, 0, 1, okay, 1, 0, 1, 1. Okay, 1, 1, 1, 1. Okay, okay. How I'm going to fill up the output in the sense based on that JK table flip flop. So look at the table. So for example, what is the meaning is, J input is 0 and then K input is 0. The previous stage output equal to 0. And then what happened? I'm going to predict that what is the current output. Okay, look at the table. What happened? If J equal to 0 and then K equal to 0 in the sense, no change. No change in the sense it will retain the previous stage. Okay, it will retain the previous stage. Okay, that is called as a no change. Okay, for example, what is the previous stage here? The previous stage output equal to 0. That's why I'm going to write as a 0. It is okay for you? Sir, here my three inputs are available, J, K and Q1. Q1 is nothing but previous stage output. Okay, how the sequential circuit is going to take the decision? The current input plus the previous stage output. The previous stage output. JK is called as the current input. Q1 is called as the previous stage output. Okay. So now I'm going to defining what is the current state output. How do you do that? My J equal to 0 and K equal to 0. J equal to 0, K equal to 0. If it is there, what happen? It will retain previous stage. What is the meaning of previous stage? What is the previously output value is there? What happen? It will retaining it. That is the meaning. Here, look at that. Q1 is otherwise called as the previous stage output. What is the previous stage output? 0. That's why I'm going to return as 0. Okay, it's okay for you? Hello? It is okay for you?
Yes, sir.
Okay. Next, my input is 0, 0. Okay, what is the 0, 0? 0, 0 in the sense it will retain the previous state output. So look at that. What is the previous stage output? 1. So definitely the output value equal to 1. It is okay. It is okay. Okay.
Yes, sir.
Next. What is the next input combination? 0 1. Okay. Look at the table. Okay. 0 1. Okay. 0 1 in the sense definitely the current state output, the what is the output in the sense? 0. So what is the meaning is, if k value equal to 0, k value equal to 0 in the sense, definitely whatever whatever it is the previous output, it does not considering it. Okay, it going to generate output value equal to 0. Okay, look at the table. இங்க பாரு, look at the table. My input combination is a 0 1. 0 1 in the sense, what is the mean? K value equal to 1 in the sense, definitely the current state output equal to 0. That thing is called as a reset. That's why I'm going to write as 0. Sir, you may ask the question, sir, why you are not consider previous state output in the sense? Sir, clearly they are defining it. In the input is 0 1 in the sense, I'm not consider the previous state output. Definitely the current state output equal to 0. That's why I'm going to return as reset. It is okay. Okay,
Yes,
next.
sir.
What is the next input combination? 1 0 1 0. Look at the table. What is the 1 0 1 0 in the sense, definitely it's going to produce output equal to 1. So while predicting the output, it not consider the previous stage output. Okay, 1 1. Okay, it's okay. It is okay for you.
Yes, sir.
Okay, next, what is the last combination? The last combination is a 1 1. So what we are defining it, what we have defining it, um, okay, it's going to perform complements operation. Okay, so how it going to perform complement in the sense? For example, it look at the previous stage output. In this combination, the previous state output equal to 0. So for that it perform complement operation. So what happen is 1 here 0. So it's okay for you. It's okay for you. Okay, once
Yes, sir.
again, whether I want to repeat that. Okay.
No, sir.
Okay. So this is nothing but the characteristics table for JK flip-flop. Okay, the characteristics table otherwise called as a, we are going to defining the behavior of JK flip-flop. Okay. Okay. So based on that, what happens? I'm going to form. Okay, I'm going to form the characteristic equation. I will tell that what is the meaning of characteristic equation. Okay, the characteristic equation. Okay, it is also tell that this the characteristic equation. Okay, what is the meaning of characteristic equation? In the sense, it will tell that the behavior of circuit, it will tell that the behavior of circuit, the circuit in Boolean algebra representation. Boolean algebra representation, that is called as a characteristic equation. Okay, so now what I'm going to do, I'm going to form, and now I know that the behavior of the flip-flop. Now what I'm going to do, I'm going to form Boolean algebra. How do you do that? This is a three variable input. Three variable input in the sense, how do you form the Boolean algebra? Make use of kernel map. Am I correct? Okay, for that what I'm going to do, I'm going to draw the kernel map. I'm going to take three variable kernel map. It associated with 8 cells. Okay, Q1 JK. Okay, 0 1 0 0 0 1 1 1 1 0. Okay, so look at that output. Then what are the places output equal to 1? Here the output value equal to 1. So 0 0 0 0 1. Okay, 0 0 1. Okay, what about next place here? 1 1 0 0 1 0 0 1 0 0. Okay, What about next? 101. 101. What about next place? 110. Okay, 110. Okay. Okay. So now what is the next step? You want to perform grouping. Okay, this is one grouping. Okay, this is another grouping. This is another grouping. Okay. Okay. Now what happened? You are going to minimize the equation. If you do that, what is the answer? So if you do that, what is the answer? So this is a group one. Okay, this is a group two. Okay, if we do that, what happens, sir? So Jn, Jk, okay, 0, 1. This is a constant. Okay, this is a cancel. So Jk, sorry. What happens, sir? This is a 0. Q1 is 0, 1. What about Jk? Jk is 0, 0, 1, 0. What happens, sir? This is a cancel. This is a cancel. The answer is K bar. Sorry. Only Q1 is only 1. Okay. Okay, what happens, sir? The Q1, Q bar. Okay, what about next group? G2. G2 is Q1, JK. What is the Q1 value? 0, constant. What about JK? The JK is keep on varying 1, 1, 1, 0. What happens, sir? The Q1, okay, this is a cancel. J. Q bar, J. Okay. So final characteristic equation is nothing but, okay, finally I'm going to write the characteristic equation. The characteristic equation is Q suffix n plus 1 equal to J Q n bar plus K bar Q1. Okay, that is called as the characteristic equation. The characteristic equation means it's going to tell that the behavior of the circuit in the Boolean algebra of representation. So that is called as a characteristic equation. Okay, do you have any queries? Do you have any queries?
No, sir.
The next concept is, next thing is, so whatever I represented, okay, whatever I have written in the Boolean algebra, okay, that can be represented in a realization format. The realization in the sense circuit format. Okay, how do you draw that? Okay, two NAND gates are required, one OR gates are required. Okay, okay. So one is J, another one is a K bar. So here what happened? I'm going to add the bubble. Okay, what is the okay? So how we are going to draw in the sense, okay, the Q and then Q bar, otherwise called as the the previous stage output. Okay, the previous stage output. Okay, now what I'm going to do, I'm take the output. It is a feedback for my circuit. Okay, so J here. This is called as a Q1. Okay, Q1. Okay, okay. Did you understand what I am trying to say there? Q and then Q bar is called as a memory element. That is called as a previous stage output. So whenever you are going to perform any sequential operation, what happen? So sequential circuit, what happen? It will take the current input. Okay, the current input is nothing but JK. What is the previous output is called as a Q1 Q bar. Okay, that's why I'm going to write this. I'm going to draw the circuit like that. It is okay. It is okay for you.
Yes, sir.
So next, I'm going to introduce another terminology that is called as a excitation table. Okay, I'm going to tell that. What is the meaning of excitation table? Okay, I'm going to tell that what is the excitation table. Okay, excitation table, what it going to tell that if the previous stage output is this is called as a previous stage output. The previous stage output q n plus 1 is called as a the current the current output. Okay, the current output. So what I am trying to say that the previous stage output is 0, the current output 0, in the sense what is the combination for j and k that can be represented in the tabular format, that is called as the excitation table. So in order to do that, you needed the characteristic table for jk flip flop. Okay, in order to do this operation, you needed the characteristic table for jk flip flop. Okay, so already we have seen jk q1. Okay, 0 0 0 1 1 0 1. Okay, 0 0 0. Okay, so next 0 0 0 1 1 0 1 1. Okay, 1 1. Okay, so already we have seen that. Okay, I'm going to first I'm going to write the table 0 1 0 0 1 1 1 0. This is the table. Okay, in order to fill up that excitation table, you needed characteristics table. Okay, this is the table. Okay, so look at the table. Suppose my current input, my previous stage output 0. Okay, the current output also 0. In the sense, what is the combination for jk? Okay, what is the combination for j and k? So what is the combination? Here the previous stage output 0, the current output 0. What is the combination? This is one of the combination. Anything else? Here one of the combination is there. Okay. Here what happened? Okay. Okay. Here what happens, sir? Here j k. One of the combination is 0 0. Another combination is another combination is 0 1. Okay. In which are the places the value is changed, that can be denoted as a don't care. Okay. Okay. Now what I'm going to do? 0 don't care condition. It is okay for you? So what is the objective of excitation table? In the sense, I'm going to take the previous state or stage, both are same meaning. The previous, I'm going to take the previous stage output, parallelly current stage output. If this is a 0, this is a 0. In the sense, what is the input combination for JK? Two input combinations are available. This is a one input combination. This is another input combination. Okay, here j is similar, but k is a varying. Okay, if k is a varying, in the sense that can be represented as a don't care condition. What is the meaning is, if the previous stage output is 0, the current output 0, in the sense what is the input combination? In the sense either 0 0 or 0 1. That is the meaning. That can be represented as a don't care condition. It is okay for you? Hello.
Yes, sir.
Okay, now what is the next combination? My previous stage output equal to 0, the current state output is 1. In the sense, what is the combination for jk? Okay, what is the combination for jk? Okay, so look at the table. Okay, 0 1 0 1. There is a 0 1 0 1 0 1. What is the input combination? Okay, 1 0. Another one is 1 1 1 0 1 1. Okay, how do you do that? So J is both are similar, but K is a varying. If K is a varying, in the sense, it can be represented as a don't care condition. Okay. Similarly for rest of the cases. Okay. What about next case? What about next case? The next case is 1 0 1 0. Where 1 0 1 0 combinations are available? Here 1 and 0. What about next case? 1 and 0. Okay, 1 0. So what is the input combination? This one and this one. So 0 1 1 1. What happens, sir? J is keep on varying. That can be represented as a don't care. This is a 1. X don't care condition 1. Okay, what about last input combination? The last input combination is 1 1. Okay, so where 1 1 is there? Okay, this is a 1, this is a 1, this is a 1, this is a 1. What is the input combination? This is okay. So 0 0 1 0. Okay, J and K. So what happens, sir? This is a keep on varying. That can be represented as a x. This is a 0. This is called as the x 0. It's okay for you. That is called as the excitation table. Okay, that is the excitation table. It is okay for you. It is okay for you. I'm asking for
Yes,
yes.
sir.
Okay. Okay. Next thing is next concept is called as a state diagram. Okay. If we consider any next topic is called as a state diagram. State diagram. State diagram. Okay. If we consider any flip flop, it associated with a two state. It associated with any if you consider any flip flop associated with two state, one is 0, another one is 1. Okay. Okay. So now what I'm going to do, okay, 0 or 1. Okay. So how to draw the state diagram in the sense, for example, in order to draw the state diagram, you needed a characteristics table. So already I said, what I'm trying to say that any, if you consider any flip flop, it associated with the two input. Sorry, it associated with the two output, namely called 1 comma 0. Okay. So, okay, let's say, for example, here what I'm going to do, I'm taking input combination is a 0 0. Okay, I'm taking the input combination is a 0 0. Okay, now I'm currently in Q1 state. Okay, okay, I'm currently in Q1 state. Suppose this current state, suppose I'm providing input as 0 0 in the sense, I'm going to provide input as a 0 0 in the sense. Okay, what is the output? The output is you are retaining the same state. Okay, how do you draw? I will tell that how do you draw the state diagram in the sense. This is called as a output. It associated with the two output, either 0 or 1. That can be draw like that. Okay. How do you fill up that? How do you draw the state diagram in the sense? First, you look at that the input combination. What is the input combination? I'm there in the 0 state. I'm taking input as 0 0 in the sense. Okay. Okay. How the sequential circuit is working? Sequential circuit is nothing but the current input, okay, and then previous state output. I am correct. Previous stage or state output. What is the here? What is the current input? 0 0 0 0. What is the previous state output? The previous state is there 0. So I am there in the 0. I'm going to take input as a 0 0 in the sense again what happened? I'm there in the 0 state. That's why I'm going to write written as like that. Next, you consider next combination. What is the next combination? My input is 0. The previous state output is 1. What is the final output? I'm there in I'm there in 1. So previous stage output is 1. Whenever I'm going to take input combination is 0 0 0 0. Again I'm there in 1 state. Okay. So what about next input combination? So I'm there in this 0 state. I'm going to take 0 1. 0, 1. I'm going to take 0, 1. So what is the final output? The final output is 0. What is the meaning is my current input is 0, 1. Okay, my previous state is 0. Okay, the previous state is 0. I'm going to take input as 0, comma 1. So what is the final output? 0. What is the meaning is again I'm there in the same state. That's why I'm going to write it as 0, 1. Okay, what about next input combination? The next what is the next input combination? The next input combination is 0, comma 1. The previous state output is 1. What about the current output? The current output is 0. Okay. Sorry. Okay. So where I'm there in the one state. So what about the current output? The current output is 0. So I'm going to draw the line from 1 to 0. Okay, 1 to 0. What is the input combination? 0, comma 1. 0, comma 1. Okay. What about next? What about next state? I'm there in the 0 state. I'm there in the 0 state. I'm going to take input as 1, 0. 1, 0. So what is the final output? One state. So you're going to draw the line from 0 to 1. So what is the input combination? 1, comma 0. Okay. What about next input combination? I'm there in the first state. I'm going to take the input as 1, comma 0. So 1, comma 0. What is the current output? The current output is 1. Okay. I'm there in the first state. I'm going to take input as 1, comma 0. The final output is 1. What is the meaning is I will retain same state. Okay. What about this? I'm in 0 state. My input combination is a 1, 1. Okay. 1, 1. What is the final output? 1. Okay. 1, 1. 1, comma 1. What about last? So I am there in the one state. I'm going to consume input as 1, comma 1. What happens? Okay. The output is 0. Okay. That is called as a state diagram. That is called as a state diagram. Do you have any queries?
No, sir.
Okay. If you know the characteristics table, you can easily draw the state diagram. Okay. It is okay. I am asking for all of you.
Yes, sir. It's okay, sir.
Okay. So next I'm going to take another flip-flop that is called as a T flip-flop. Okay. Next I'm going to take another flip-flop that is called as a T flip-flop. T flip-flop. Okay. So this is a specification for T flip-flop Q and Q bar. T. Okay. So what is the meaning is? If the t value equal to 0 in the sense j value equal to 0 and k value equal to 0. Okay. If t value equal to 1 in the sense, okay, j value equal to 1 and k value equal to 1. Okay, that is the behavior of T flip-flop. Okay, from this what happened? I'm going to write the truth table for T flip-flop. Okay, how do you draw that? T equal to T. Okay, what happened? This is the input. So this is the current output. Okay, otherwise called as the next stage output. Okay, if I'm going to provide the input is 0. Okay, what happens, sir? Already you know that the behavior of JK flip-flop. What is the behavior? Okay, QN. Okay, the input combination is a 0, 0. What happened? It will retain the previous stage. Okay, no change. That can be represented as a QN. Okay, So if the next, what is the next one? 0, 1 in the sense what happened? The output value is a reset. 1, 0 in the sense 1. 1, 1 in the sense it's a complement. Already, just now we have seen JK flip flop. Okay. So okay. So based on that, you should fill up the truth table. What happens, sir? T value equal to 0. T value 0 in the sense what happened? J value equal to 0, K value equal to 0. What is the behavior? No change. What happened? So it will retain the previous stage. The next 1. 1 in the sense what happens, sir? K equal to 1. Sorry, J equal to 1, K equal to 1. So what is the behavior? The complement. Okay. This is the truth table for T flip-flop. But it's okay. It is okay.
Yes, sir.
Yes, sir.
So based on that, what happened? I'm going to draw hereafter. What happened? Once I find out the truth table, what happened? I'm going to draw the characteristics table and followed by characteristic equation and followed by excitation table and state diagram. That is a procedure. Okay. You are going to tell the answer. Okay. The characteristic table. The characteristic table. Okay, here what are the input combinations are available? Only one input, and then the previous stage output, that is called as a Q1. Okay, so two input variables are available. How many input combinations are available? 4, 0, 0, 0, 1, 1, 0, 1, 1. Okay, okay. My input is 0. My input is 0. Okay, my input is 0. Okay, look at that. How do you fill up the table? KQ n plus 1. How do you fill up the table? My input is 0. Okay. Uh, my input is 0 in the sense what happened? Qn. Q1 in the sense it will retain the previous state. Okay. It will retain the previous state. What is the previous state? Qn is called as the previous state. What is the value is there in the Qn? Q suffix and 0. That's why I'm going to write it as 0. Next, what is the next combination? My input is 0 in the sense what happened? It will retain the previous state. So what is the previous state? 1. So it will retain 1. What about next? My input is 1. What happened? If the input is 1 in the sense what happened? It will it going to complement of the previous state. Okay, what is the previous state output? 0. It's complement 1, 0. Okay, that is called as the excitation table. Sorry, this is called as a characteristic table. It is okay for you?
Yes, sir.
Okay. Next, what is the final output? Already I said the characteristic table is called as the behavior of flip flop. Am I correct? So next thing is nothing but the characteristic equation. What is the characteristic equation? The characteristic equation is called as a behavior of the flip flop that can be represented as Boolean expression. Characteristic equation. Okay. 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 How do you form the Boolean expression? Okay, look at that characteristics table. How many number of variables are available? Two variables are available. So in order to form the Boolean expression, so which type of kernel map is required? Two variable kernel map is required. Okay, Q1 and then T. Okay, 0, 1, 0, 1. Okay, you fill up the table. What happens, sir? Okay, it's going to produce output as. Okay, then what is the next state output is T bar Qn plus T Q bar n. Okay, this is called as uh, the characteristic equation for T flip flop. Okay, it's okay for you?
Yes, sir. So,
Okay. So from this, what happened? You should write the realization, the circuit diagram for flip flop. How do you do that? Okay, how do you do that? How do you do that? Okay. So already I said this is the sequential circuit. How the sequential circuit is working on the current input. Okay, the current input is a T. Okay, the current input plus the previous stage output. What is the previous stage output? The previous stage output is, what is the previous stage output? The previous stage output is Q and Q bar. Okay, that's why I'm going to provide as a feedback. Okay, T bar Qn plus T Q bar N. Okay, this is nothing but exclusive OR gate. This is nothing but exclusive OR gate. Okay, it is okay. It is okay for you.
Yes, sir.
Okay. The next, what is the next thing? Excitation table. What is the excitation table? The excitation table we have seen. What is the, anyone tell that what is the excitation table? Anyone tell that what is the excitation table? The excitation table is nothing but we are going to take the previous stage output and then the next stage that is called as the current stage output. Okay, so suppose 0 0 in the sense we are going to tell that what is the input combination for T. Okay, that is called as the excitation table. So in order to do that, you needed a characteristic table. Okay, in order to do this operation, you needed characteristic table. Okay, what is the characteristic table? Just now we have seen, okay, 0 0 0 1 1 0 1 1. Okay, okay, we have seen just now we have seen 0 1 1 0. Okay, okay, if you fill up the table, what happens, sir? My input is my previous stage output is 0. The current stage, that is called as the next stage output is 0. Means what is the input combination? 0. Anything else is there? No, no problem. So what about next one? Uh, 0 1 0 1. Okay, 0 1. Okay, okay, 0 1. Okay, my previous stage output is 0. The current stage output is 1. What is the value of T? So only one combination is there, 1. Similarly for 1 0 1 0 1 0 1 0 1. Okay, next one is 1 1 1 1. What is the T value? 0. Okay, it is okay for you.
Yes, sir.
So next, you should draw that state diagram. How do you draw the state diagram? Okay, this is called as excitation table. Next thing is the state diagram. How do you draw the state diagram? Already is it, if you consider any flip-flop, it associated with the two output, namely called 0 comma 1. 0, another output 1. Okay, how do you analyzing it? How you are going to analyzing it? Okay, first I'm there in the 0 state. I'm there in the 0 state. Okay, I'm going to consume the input is 0. What is the final output? The final output is 0. Okay, so I'm there in the first state. I'm there in the first state. I'm going to consume the input is 0. What happened? Okay, what happens, sir? I'm there in the that stage itself. Okay, first state. I'm there in the 0 state. I'm going to consume input is 1. Okay, what happened? The state changed from 0 to 1. Okay, what is the input combination? 1. What about last combination? I'm there in the 1 state. I'm there in the 1 state. I'm going to consume 1. I'm going to consume 1. What happened? Okay, the state is changed from 1 to 0. Okay, that is called as a state diagram for T flip-flop. Okay, it's okay for you.
Yes, sir.
Okay, uh, that's all about T flip-flop. Remaining thing we will see next class. Okay, now I'm going to take the attendance.